All right, welcome to part 3. Remember, I told you topic 1.1 is a really good one. So we are in part 3 now of the normal distribution. And we've learned all about the normal distribution. We've learned how to use some normal distribution calculations with our calculator involving z-scores and proportions above, proportions below. Now we're going to look at what I consider the ultimate problem. This is a very difficult problem, not so much because of the statistics, but mostly because it involves some pretty tough algebra. But this type of problem does come up on the AP test every now and then, so it's definitely worth practicing, and you're going to see one in this class as well. All right, here it is. All right, Cheesy Crackers is a competing company of Cheez-Its. They claim that their box filling machines, the machines that fill up their boxes, are very accurate to the mean. They claim that only 5% of boxes are over 16.3 ounces, and that 3% are below 16 ounces. So that's pretty good. But the question is, what mean and standard deviation is their machine operating at? What are their parameters? So this is a very tough problem where we're trying to find mu because we have no idea what it is. We're trying to find standard deviation because we have no idea what it is. We were only given 2 pieces of information. 5% of boxes get over 16.3 ounces. And we were also told that 3% of boxes get under 16 ounces. All right, so based only on these 2 pieces of information, we need to figure out what the mean and standard deviation is. So first we have to understand that we do know z-scores. Remember, because of invert normal in our calculator, we could get z-scores as long as we know the percent below. So for example, we know that 5% are above 16.3. Well, using our calculator, we could figure out the z-score for that value. So we're going to grab invert norm. Now just keep in mind, remember, calculator doesn't accept above, it only wants the below. So if we're talking about 5% below, that means 0.95 or 95% is below, for the 5% above. So always got to be concerned with that. So that's a z-score of 1.6449. 1.6449. I'm going to write that down. All right, now the other piece of information they told us was that there is 3% under 16 ounces. So this time they did tell me the under, right? That is an under, so I'm going to use 0.03. Don't switch and use 0.97, because remember, we want the under. We like the under when it comes to using invert norm. And that gives us a z-score of negative 1.8808. Okay, so now what we have to do is take the information that we gained right here and somehow create some equations. Well, here we go. Remember, these are z-scores, right? So what's a z-score? A z-score is equal to a particular value. Oh, wait a minute, I know that value, 16.3, minus the mean divided by the standard deviation. So again, remember, this z-score represents the value with 5% above it, 95% below it, and I was told that that value was actually 16.3 ounces. This other z-score is equal to 16 ounces minus the mean divided by the standard deviation. So once again, this z-score of negative 1.8808 is a z-score for 16 ounces, which we know has 3% below it. So with these 2 pieces of information, I was able to generate 2 equations. Unfortunately, those 2 equations have 2 variables, sigma and mu, that I don't know. So now it becomes a very difficult algebra problem. So what you're going to see on the next page is how to solve this algebraically. But at this point, the statistics is completely done. The statistics is basically taking the 2 pieces of information I was given, find the z-score, locate that z-score in terms of the z-score formula, like I actually set it equal to the formula. Now is all the algebra. So if you can understand what I have talked about thus far, you're done with the statistics part. Now we got to move on to the algebra. So here's how you solve an equation with 2 variables you don't know, and I'm going to use substitution. So here is all of my math work. First, I started off with the left equation that represents the 5% of boxes that are over 16.3 ounces. I solved for mu. I multiplied by sigma to the other side. I subtracted 16.3, And then I had to get rid of the negative in front of the mu, so I multiplied everything by a -1, which generated negative 1.6449 sigma plus 16.3 equals mu. Now what I want to do is substitute that into the other equation for mu. So this is the other equation that represents 3% of boxes that are under 16 ounces. So the first thing I did was I multiplied over by sigma. So now I have negative 1.8808 sigma equals 16 minus mu. Now what I'm going to do is a substitution, right? I'm going to take the mu that I know from the left equation, and I'm going to substitute it into the mu for the other equation. Now, you could also solve for sigma and substitute sigma, and there's probably 6 different ways that you could apply substitution here. I'm just doing it the way that I personally think is easiest, but it could certainly be done other ways. If you're good at algebra, you should be able to figure out those other ways. All right, so now starts my next step, which is actually substituting in. So I have the negative 1.8808 sigma equals 16 minus, but instead of mu, I'm replacing it with what mu is, negative 1.6449 sigma plus 16.3. I then have to distribute that negative, which is going to give me positive 1.6449 sigma and minus 16.3. Now I have a pretty easy algebraic equation to solve. First off, I'm going to subtract the sigma to the other side. That's my variable. So I'm going to subtract 1.6449 sigma to the other side. That gives me negative 3.5257 sigma. That was the negative 1.8808 sigma minus 1.6449 sigma, and that's how I came up with the negative 3.5257 sigma. Then I have like terms over here. 16 minus 16.3 is going to be negative 0.3. And then to solve for sigma, I just simply divide the negative 3.5257 over to get sigma to be 0.0851 ounces. That is a much smaller deviation than Cheez-Its. If you remember, Cheez-Its had a standard deviation of 0.2. Much smaller, which means their machine is much more consistent to dumping the correct amount of Cheez-Its, or these are actually called Cheez-It Bites, into every box. All right, now how do you find mu? Well, go back to this equation right here that had mu all by itself, and now that I know what sigma is right there, I just have to substitute it in. So here's that equation right here, and I'm just going to substitute in sigma for 0.0851. Do the multiplication and add the 16.3, and you get 16.16 ounces for the mean. So the parameters that this new company's machine is working with is 16.16 ounces. That's slightly smaller than what my machine at Cheez-Its factory was working with. And their standard deviation is a little bit more accurate at 0.0851 ounces. So this is some tough algebra, not going to lie. It's not calculus, okay? This isn't even pre-calculus. It's certainly not geometry, but it's just some upper level algebra, which you guys should be somewhat decent at, especially after me showing you. Keep in mind, I kept 4 decimal places. To be honest, if you keep less, you're going to be less accurate than I am. If you keep more, you will be much more accurate. So I definitely suggest keeping at least 4 decimals through your solving process. That way you're fairly accurate. To be honest, even keeping 4 decimals, these numbers are, I mean, they're correct. They're the right numbers, but they're actually going to be a tad off from what I want because I wasn't 100% accurate. Keep more decimals and you could be more accurate, but I'm happy with 4. All right, so this is the toughest problem you're going to get, but it all comes back to this idea of taking what they told you, this idea of 5% over 16.3 and 3% below 16, and turning that information into equations that we know about z-scores. So hopefully this helps you, and this definitely will be on the test, and this is definitely the most algebra, right? The only reason why this is hard is not because of statistics, it's hard because of the algebra. So make sure you practice it, and we'll do a couple more examples in class to get you ready for it.